Welcome back, my friends. Prime factorization. First, we'd like to remember what are the prime numbers. The list of prime numbers, the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. What are prime numbers? Prime numbers are numbers that have only two factors, 1 and itself. What does this mean? This means that 2 can be written as only 2 times 1, and 3 is only as 3 times 1, and 5 is only 5 times 1, and all the other numbers, for example 29 is also equal to 29 times 1. But do I have any two numbers that can be multiplied together to get, for example, 29? Think about it. No, 29 is a product only of 29 and 1. And all these prime numbers are called prime numbers because they are a product of 1 and itself. So, if we have a number that is not prime, we call it a composite number. So, we can write every composite number as a product of prime factors. And this is called the prime factorization of a number. And we can use a factor tree that shows the prime factorization of a composite number. What does this mean? Let's see some examples to explain this. If we have a number 36, we want to make 36, we want to write it as a product of prime numbers or prime factors. So we'll start always by thinking about 2. Is 36 can be a product of 2 and another number? Yes. 36 can be a product of 2 times 18 because 2 times 18 is 36. So we started the tree here by two branches, 2 and 18. And as you know, 2 is a prime number, so we stop here. In this branch, we do not continue. And we look at 18. 18 is not a prime number. It is also a composite number. So we will make another tree, two branches for 18. And 18 is also a product of 2 times 9. Now you have 2 also here, so you'll stop on this branch and we'll continue our tree on the other branch, which is 9. So we'll make 9 as, because 9 is a composite number, so 9 is a product of 3 and 3, 3 times 3. Now you have 3 also and 3. These are prime numbers, so you will stop here and stop there. So now our tree is complete. As you see, our branches or our leaves stopped at all prime numbers, which are 2, 2, 3, and 3. So this means that the prime factorization of 36 is 2 times 2 times 3 times 3. So you can check this by multiplying 2 times 2, and 2 times 2, you know, it is 4. 3 times 3 is 9, and if you multiply 4 times 9, you will get 36. Let's take another example. If we have a number 63. Now 63, can it be, it's a composite number, of course, it is not prime. But can we start by 2 times a number to get 63? Of course not. 2 is not here because 2 is an even number and 63 is not even. So we can check if it can be divided by 3. You can check here by long division. 63 divided by 3. Now 6 divided by 3 is 2. 2 times 3 is 6. Subtract and get down to 3. 3 divided by 3 is 1, and 1 times 3 is 3, and remainder is 0. So I got 63 is 3 times 21. 3 times 21. And 3 is prime, so I look at 21. 21 is a composite number, and it can be a product of 3 times 7. Now 3, 3, and 7. These are all prime numbers, so my tree now is complete. And this means that the prime factorization of 63 is 3 times 3 times 7. And you can check by multiplying 3 times 3 is 9. And 9 times 7 is 63, which is my number. And now it's complete. Let's take one more example. 75. Can I start by 2 times a number? Of course not, because 75 is not divisible by 2. Can I start by 3? Yes, I can start by 3. But in this time, I will start by 5. Okay, I can also start by 5. So 75 divided by 5. 7 divided 5 equal 1. 1 times 5 is 5. Remainder 2. Get down the 5. 25 divided by 5 is 5, which is 15 here. And of course, the remainder is 0. So it's 5 times 15. And the 15 is a composite number, which is a product of 3 times 5. Now we have 5, 3, and 5. And let me tell you something. If I want to write the prime factorization, it's better to write it in order from least to greatest. So if you want to arrange these, so it is not 5, 3, and 5, it is 3, 5, and 5. So 3 times 5 times 5. And if you want to check, 3 times 5 is 15. And if you multiply 15 multiplied by 5, you get 75. Hope you understand. I like the lesson. So please subscribe and leave any comment. Thank you. Bye.